I'm Dr. Paul Houle, and in this issue of Radon Continuing Education, I want to describe to you the results that were found from an experiment done to determine what kinds of tampering produce what kinds of effects on radon monitoring. This issue is based to a large degree on an article that was recently published, the title of which you see here, Study of the Effect of Tampering and Its Detection During Short-Term Tests. Now, the motivation for considering tampering is at least twofold. First, we'd like to know if there has been some tampering done to determine whether or not the results that we find from our detectors is legitimate. And secondly, in the most recent EPA protocols, you'll see here that there's a statement in the protocols indicating that the test should include methods to prevent or detect interference with the testing conditions or with the testing device itself. Now, the goals of the experiment that was performed is this: to investigate the ability of detectors to detect the existence of non-standard conditions and to quantify the effect such conditions have on results. In other words, we'd like to know, first of all, what kinds of tampering might be tried, and two, how much of an effect will they have on the measurements themselves. Now, the way this experiment was performed is this. The Pennsylvania DER funded this experiment, and it was awarded to Bill Broadhead and Sid Porter. What was done was a series of detectors were placed into a home by Bill and Sid to make a radon measurement in that home. Then Bill and Sid left, and Bob Lewis from the Pennsylvania DER, he and his staff went down and they tampered with the devices. They did things to try to affect the results that those devices will then determine. Then, before Bill and Sid came back to retrieve those detectors and their data, Bob Lewis and his staff removed the tampering effects so they couldn't be seen. And so now we could compare what effect tampering would have, how detectable is it by some experienced testers, and therefore have some handle on what kinds of tampering we should look out for and what kinds of things we might try to prevent that kind of tampering from occurring. Now, the study was quite elaborate. It covered 4 houses, 4 different style homes, and you can read about those homes in your packet, 19 different detectors, and was run over you see here the fall of '92 and the winter of '93. And let me point out at this point, too, that you should be in your text at this point following along with these visuals, which you'll also find in your text. This way, if you have any thoughts, you want to make notes, you can make them right there on the visuals as you go along. Now, with passive monitors, such as charcoal canisters, electrets, really the only thing you can measure is the radon concentration. But with active monitors, there are other things that can be detected. And you see here that these were some of the parameters that were watched as the time of deployment passed. Carbon dioxide concentrations, radon concentrations, working levels, indoor and outdoor temperatures were monitored, humidity changes, pressure changes, and equilibrium ratios were also reviewed. Now, the methods of tampering that were tried are these. The simplest kind of tampering to try is the opening of windows. So it's obvious if you're putting a measurement in a basement, for example, then you open the windows in the basement. That's an easy thing to do. And so that was looked at. And we're going to look in detail at that. The diverting of outdoor air to detectors, in other words, without opening windows. We're going to look at that. Moving detectors to low radon areas. In this case, for example, you could simply take your detector, put it outside, and then before the tester comes back to pick it up, put it back in the house. That's a real possibility. We can agitate the ear. We should expect that if you're going to agitate the ear, that the plate out should increase, and therefore the working levels and equilibrium ratios should drop. So fans were tried in the rooms to try to agitate the ear and get more plate out to occur. Filtering the room air. You could put a high efficiency filter or even a low efficiency filter, and that would tend to filter out the working levels, filter down the values of the working levels, filter out the daughter products. You can try covering devices. You can take an e-perm, for example, or a charcoal canister, or a continuous monitor such as this. You could try covering it up with a bucket or covering it with a garbage bag. We're going to look at what effect those kinds of things have. And by the way, we're also going to look at what kinds of things we can do as testers to help diminish those kinds of attempts. Instrument filters. Many devices, many active monitors, such as here I have a Pylon AB5, use a filter in doing their ear sampling. And so ear is drawn in through the filter and then into the device for the purposes of measuring the radon concentration. And what would happen if we put a coffee filter over this? What effect will that have? We're going to be looking at fairly common household products that might be used for the purpose of tampering. Readjusting the location of tubes. Again, let me return to the Pylon here. And the Pylon monitor would be sitting in a room just as you see it here, typically, except it would be on. And the room air is drawn in by a pump through this filter and into the radon monitor to determine the radon concentration. Suppose I just took another length of tubing, suppose I have another length of tubing, and all I do is hook it onto here, like this, and then connect this far end of the tubing, put it next to a window. Then the ear that's being sampled by the monitor would be outdoor ear to a large degree. Any indoor ear that it would be measuring would be diluted by some outdoor air as well. So there's an interesting tampering attempt that could be tried. And changing pump flows. Monitors, active monitors like the Pylon and many other monitors, typically can use a pump to draw air into the system. And suppose we change the pump flow rate. We lower the pump flow rate. What effect will that have on the radon concentration determined by the monitor? Now, you've probably been thinking, as I've mentioned each of these items, you've probably been thinking, oh, that'll have an effect, that won't have an effect, that'll have a large effect. Well, this experiment was designed to determine how much of an effect. And since, as you will see, it's impossible to eliminate without superhuman effort all of the tampering that might be tried, we should at least take steps to diminish the potential for tampering for the very easiest of things. So let's begin with the very first item that I mentioned, which was the opening of basement windows. Now, this is going to seem, some of it's going to seem pretty obvious to you, but at least here we've quantified, or I don't want to say we, the effect has been quantized with regards to how much the concentration is affected. And as you see, the larger the opening of the windows, the more you open the windows, the more the radon concentration is going to drop. Now, that should be entirely transparent to you. And values from 30% to 85% were found in this study. That's a pretty big effect. And at the high concentrations, you could see that an 85% drop would drop a fairly high concentration to below the action limit. So the opening of windows is going to be a distinct problem. We're going to have to watch for that. Now, with a continuous monitor that prints out hourly results, for example, you can get a graph that looks something like this. And what we're plotting here is radon concentrations on the vertical axis And of course, there's a number of things being plotted. I want to discuss two of them. One, the radon concentration that you see here, which is identified in the graph by the square blocks. And here, this is typical. No tampering has occurred yet. Radon concentration going down, fluctuating up and down. This is over a period of a half a day to a day from here to here, say. And here's radon concentration going up, coming down, going up, coming down. All of these results would be okay. None of that is bothersome. These are typical fluctuations in the radon concentration, except here you'll notice that the concentration starts to rise up again and then abruptly drops down to values in the vicinity of 1 picocurie per liter, which, of course, as we know, is just about the outside air temperature, outside radon concentration. And so one other thing we can look at, too, beyond just the radon concentration, is the ratio of the radon concentration in the first floor to that in the basement. In other words, suppose the first floor radon concentration is 2 and the basement concentration is 6. Now in that case, the ratio of the first floor to the basement would be 2 divided by 6, or 0.3. And typically, first floor concentrations are going to be lower than basement concentrations. Makes sense. First floor is a little further away from the source of radon gas, and so its concentration is going to be lower. And it's fairly typical to see values 30, 40, 50% lower on the first floor than you get, say, in the basement. Now, I know there's an exception to this, specifically when you have forced hot air systems and you're drawing air from the basement and you're putting it up into the first floor. Then, of course, the first floor concentrations tend to get higher. But barring that, so excluding that exception, you should expect that the higher you go in the floors of the home, typically the lower the concentration is going to be. And you see that here, very typically. The ratio given by these little X's of the first floor to the basement is very, very low. And in fact, that ratio is plotted on this vertical axis on the right. And you see it's sitting around here, sitting around 0.2, 0.3, somewhere in that order. There's that kind of fluctuation. And that seems okay. At the same time that the radon concentration dropped, the ratio of the first floor to the basement went up to values 2, 3, and obviously a couple of values off the graph here. That is very suspect. And it turns out, of course, as you can see here, that the basement windows had been opened by 85% at just about this time. And that's what caused the radon concentration to drop so much, and the ratio, this first floor to basement ratio, to rise so dramatically. So if you have continuous monitors that are printing hourly, you'll get this kind of data, and some of this data, at least here in this case, indicates, in this example, that tampering has occurred. Of course, if you see that data for yourself, you're doing a real measurement where you may or may not suspect that tampering has occurred. This is not conclusive. You cannot go and somehow accuse the client that tampering has occurred, but it sure would make the data suspect. And on another note with regards to tampering, some tampering might occur that's unintentional. If the client is not well educated to recognize that you shouldn't open the basement windows during the period of the measurement, then it's possible that they could do that unintentionally, not being aware that opening those windows has a big effect on the radon concentration. So as you're going to see, it's going to be important that we educate the client, and it only takes a minute or two to do that. To go on with the window issue, and I'm spending quite a few minutes on the window issue because I consider that a very possible difficulty. Here you'll see in this visual I've put the words, and the lower the window, the greater the drop. Now, what I mean by that is the lower the window is on the floor. That is, windows in the basement have a bigger effect than windows on the first floor. which have still yet a bigger effect than windows on the second floor. And where you'll see concentrations drop by 30, 40, 50% and more in the basement if the basement windows are opened, if you open the first floor windows, this article points out that the drop in concentrations on the order of 10 to 15%. So clearly the basement windows, if you're making a measurement in the basement windows are the important ones to watch out for, because they're the ones that are going to have the biggest effect on the radon concentration, and I guess I've beat that enough. You should recognize that at this point, even though that might have been transparent to you in the very beginning. Now, how can we deter the opening of windows? Well, of course, one thing that should be done is you should inform the client, don't open the windows. This is only maybe a 2 or 3 day measurement. Don't open the windows during this time. Or if you have to open a window, gee, open it for a minimum amount of time. Plan your scheduling of events so that you don't have to open the windows. If there's a workshop in the basement and you're making the measurement in the basement, you know, the fellow may not want to do some staining or painting during that period because perhaps when that's done, the windows are left open. So educating the client is very important. Now, another thing you can do for yourself that helps you as a tester recognize that the windows have not been opened or fooled around with is to use these devices. These are tape seals. Now, what you can do with a tape seal is, first of all, they are very inexpensive, is you can peel a tape seal off if you're careful, whoopee, like this, and it's a very fragile piece of tape. And you can put it on the window itself and on the window frame, on the window sill, so that when the window is closed, this seal is up tight against the window and the window sill. If the window is opened, the seal is torn. It is practically almost impossible to remove this tape from the window without tearing it. So if when you come back to pick up your detector, you find a tape seal broken, then you'll know that that window has been opened. Tape seals, and you'll see I have a few more uses for tape seals. Tape seals are an extremely inexpensive and useful tool for the radon tester. So I'm going to save that tape seal so that we can use it again, or save parts of the tape seal, what's left of it. So 2 things you can do for windows. The first of which is inform the client, and the second is you can use something on the order of tape seals. Now, another tampering technique that might be used is the diverting of outside air to the monitor without opening any windows. If you'll notice that if you have a continuous monitor, such as this one, I've attached an extra long piece of hose, obviously a little too long, longer than necessary anyway, and air would be drawn through this hose to the monitor. But if I took the far end of this hose and just put it on the windowsill, maybe I just tape it up against the windowsill because air is coming in here, right up against where the window closes, you'll find that even without the window open, that there's a modest amount of air that comes through that window seam where the crack between the window and the windowsill is. A modest amount of air comes through there, which means that the air that's being sampled by the monitor in that case would include air from the basement, assuming that's the room we're testing, and air from outside. Of course, that's going to drop off the radon concentration. You can see that kind of effect. Again, if you have a continuous monitor, the data is much more apparent. Because if you're using a passive monitor, which are good monitoring devices, they simply don't give you this kind of data. We'll find here, in this example, again, the radon is indicated on the graph by the square blocks. And so that's right here. Now, this is an interesting result where this effect was tried. Concentration is low. Well, it's lower than what you're going to see here a little later. It's down around 12, 13, 14 picocuries per liter. And these small fluctuations, to me, would seem okay, except at the very end, just before the tester returns to pick up the detector, the radon concentration now rises dramatically. Now, the tampering that had occurred in this case was exactly as I've pointed out, that the end of that hose was put next to a window, and some outdoor air was drawn in, and you can see that the concentration must have been much higher in that room than what was measured by this particular monitor. So that has a significant effect, or can have a significant effect. So one thing that could be done there is here's the way the monitor comes, let's say, and you put it on the table where the monitor belongs, and you could put, whoops, just peeling off the tape seal off the desk here, tore it up. You could take a tape seal and put it over the monitor, and if I had I guess I do have a full one here. I brought a few so I can play with these a little bit. Easy. You could just take your hose here, let's see if we can see this, and you could actually tape the end of it down, well, if you're careful. Jeez. And, well, you'll have to practice with this one, and do something like this. Now, it's going to be impossible for someone to put an extension on this hose and then run it over to a windowsill. That's just not going to happen without tearing the tape seal. So that's one thing you might try. Again, another use for these tape seals. Whoops. And further evidence that they tear easily. Okay. The next type of tampering that can occur that we're going to discuss is this business of moving the detectors to a low radon environment. Now that's most easily done with passive monitors such as the charcoal canister or the electret. You can just take these and put them outside while the tester is gone. And then if the tester tells you he's coming back Thursday at 5 o'clock to pick it up, at 4:30 you go out and you get it and you bring it back into the house. As you'd expect, the concentrations can drop pretty darn dramatically. And in fact, I would have expected the concentrations to drop enormously, but they dropped, at least in this experiment, they dropped from 49 to 87% for electrets, for this particular manufacturer, E-Perms, and charcoal canisters dropped by about 66%. Again, that's a big effect and has a large resultant effect on the concentration. The way to avoid that is you take one of your undamaged tape seals, you put it on the side of the detector, and you just fasten it down like that. I don't know if we have a shot of that, but you just take a tape seal and you fasten the whole thing down like this. Now, if the client goes to remove it, well, of course, we don't have a full tape seal there, but the tape seal will tear when the detector is moved. So actually, that will prevent it from going outside, hopefully, and it will also deter anyone from casually moving the detector. Of course, that's something else you can tell the client during the period where you meet with them to inform them of what kinds of things not to do. One thought about that is if you tell the client, don't move the detector, don't open the windows, then you're also telling the client some ways that tampering can occur. That's unfortunate, but it is my opinion that it will be more effective to tell them not to do these things than to simply not divulge that kind of information to them. So what you should have, and we'll discuss in a little more detail a little later, is a device called a non-interference agreement. This is simply a sheet of paper, a document, on which you will inform the client in print the different things that we're talking about here and anything else that you obviously want to add to the form, and then have the client sign. Now, once the client signs that, they pick up a certain responsibility for those kinds of things. They're saying, I will not, and their signature will testify to their having read the document and admitting to the fact that they will not try to do those activities on those detectors. I think that's a very powerful tool. So we want to watch out for that. Ear agitation. Just blowing the ear around in a room is expected to have some effect on working levels. As I mentioned earlier, you'll get more plate out, and therefore more of the daughters will not be in the ear, and working level concentrations will drop. It was found here that if you used one fan, you'll decrease the equilibrium ratio from a few percent to as much as 40%. And the more fans you use, the more it's going to drop. Well, that seems reasonable. There's nothing in this that's going to go against common sense. So that seems reasonable. And in the article, you will also discover that effectively there was no way to tell whether or not a fan's been in use in a room. You might want to give some thought to that. How could you tell if a fan has been on in a room? If you think of any of those things on the course evaluation form, perhaps you can pin those in and send them back to us and let us know. Another technique is called bags, buckets, and coverings. In other words, if you take your monitor and you put it here, well, let's do it with a charcoal canister to start with. You put your monitor there. It is quite possible that you could, some individual could just put a bucket over it or a bag over it. And the effect, as you see here, if you cover it up, is working levels can drop between 30 and 93%. That's enormous. Charcoal canisters can drop as much as 85%. EPIRMs are affected much less in this experiment, 13%. Now, the reason the electrets, in this particular case, the manufacturer produces them under the name EPIRM. In this case, when you open the detector, that's how you activate it. Now, room air goes into the detector, and this is not an absorber of radon. It simply detects how much radon is in the room. So if you were to put this in a plastic bag, for example, that was impervious to radon, then it would act as if it were taking a grab sample. And so its effect, the effect on this type of device will be much smaller. Covering it, for example, will have a much smaller effect on EPIRMs than it will on charcoal canisters. And as you see here, the value is down around 13%. That's not too large. It troubles me to see any kind of tampering occur, of course, but that's nothing compared to the value it has on working level measurements and the charcoal canisters. Now, this is as good a place as any to bring into the picture one other form of tampering that can occur to EPIRMs. This is the way the EPIRM is activated. As you saw, I simply unscrewed the cap and it popped up, and now it's sampling the room air here in the studio for radon concentrations. Well, if you were to put this in a home, you put a tape seal, for example, on it so that it doesn't get moved. There it is. Nobody's going to move that now. Well, the client could try to cover it, but we saw that doesn't have too much of an effect. The client could just simply come along and close it. And now it's no longer sampling room air. That's a pretty simple thing to do. However, you have a very easy thing that you can do if you're using these, and that is in the shaft, and you won't be able to see this, but in the shaft of this particular device, there's a hole in it. And you could stick anything in that hole, and I've brought a bobby pin here, and I can stick it through the hole here so that once it's stuck through the hole, I can't close the EPIRM. And I could close the bobby pin on this side, for example, and that would make it a little more solid. But then the client could easily remove that bobby pin. There are devices that are made, these kinds of seals, and unfortunately I have closed this seal, but typically the seal comes open where this narrow shaft here is not connected to this thicker shaft. Once they are connected, once they're closed, it is impossible to remove it without breaking the shaft. And so, and I'm not sure, and it's not easy to break either. So this kind of seal can be used with an EPIRM, the narrow shaft simply placed through the hole of the EPIRM shaft here, and then closed. And then it is not possible, it will not be possible to close the EPIRM in that case. So if you're using EPIRMs, clearly you should also be using some kind of method, some anti-tampering device to prevent anyone from closing the EPIRM during the measurement period. There are some other things. I was pretty impressed with the things that were tried in this tampering, and in fact, I I think if I had been on this project, on this experiment, I would have had more fun being on the side that was doing the tampering than on the other side. Hairspray was tried. You can take, for example, a charcoal canister and open it up. Suppose you have an open-faced charcoal canister and you put it in the room for measurement. You can try spraying hairspray. That's something that's probably in many homes. And in that case, charcoal canisters drop their concentrations from 29 to 94%, depending on how much hairspray you sprayed onto the can. That's a pretty massive effect, and it might be detectable by higher mass gains on the charcoal canister. Now, typically, the masses of charcoal canisters are measured before they leave the lab and again when they return from the lab. And you have typical mass gains of 2, 3, 4, 5 grams, maybe 6 or 7 grams. With the hairspray, it was found that the mass gain was around 15 grams. So high mass gains of that order might indicate the potential for tampering to have occurred. Unfortunately, another kind of fabric spray called static guard was also tried. That lowered the radon concentrations as measured by these detectors and had no appreciable mass gain in this experiment. So that one would be a much more difficult one to detect. Blowing hot air against charcoal canisters. You can see here, charcoal canisters they're simply filled with charcoal. That's very simple. And charcoal is a great absorber for all kinds of materials in the air. And the interesting thing about charcoal is you can clean charcoal by heating it to above 100 degrees centigrade. And if you heat it to above 100 degrees centigrade, what's in the charcoal effectively gets boiled off, leaving the charcoal free of whatever that material is. So they tried an air dryer, a hot air dryer, and you see here, if you run the hair dryer for 10 minutes on the detector before it's picked up, the concentration dropped by 11%. And if you run the hair dryer for 20 minutes, the concentration dropped by 50% in this experiment. Now, how could you prevent that from happening or detect that that had happened? Obviously, you can prevent it from happening by telling the client, do not interfere with the detector in any way. Another way to deal with it, to detect it, is to put a heat dot on it. Now, these, I don't have any with me, but these are small pieces of sticky paper that change color when they're heated. And so you could put a heat dot on it, and it may come, for example, as yellow. And then if when you go to pick it up, it's turned red, that would mean that its temperature has risen to above 100 degrees centigrade at some point. You can get heat dots for different temperatures, to get the right ones, obviously. And if it had changed color, you would know that that was some pretty unusual temperatures for this canister. Okay. So that's how you could deal with that issue. You can put filters over working level monitors, as we've discussed. If I were to use this device as a working level monitor, it would still be using a filter. And suppose I took another coffee filter and put the coffee filter over this filter to prevent daughter products from striking this particular piece of filter. Well, that's going to lower the working level concentration, and the effect was seen to drop it from 9% to 52%. Again, a fairly significant effect, putting filters over working level monitors. So that's something that you would have to think about, of how you're going to detect that kind of tampering. And we're going to talk about that a little later on. In all of these cases, it becomes apparent to me that it's better to deter tampering than to have to try to detect it later. And again, the non-interference agreement, if you're not using one, in my opinion, you should. And in your packet with this video is an example of a non-interference agreement. I'm not suggesting that you use that one, but it's a basis from which you could develop your own non-interference agreement. So, some of the anti-tampering techniques that we've looked at are tape seals, very inexpensive, extremely effective in my opinion. Detector placement. Let's talk about this one for a second. Where are you going to put the detector? Now, prior to deploying the detector, in this article, it's recommended that you walk around the house to see if there's anything unusual with the house. Of course, that'll only take a minute or two. Look for vents and crawl spaces, or vents that you might not see from inside the house but are apparent from outside the house. Of course, you want to have your closed house testing conditions generally, and so you want to make sure that those kinds of vents are closed. And sometimes you can see them from outside, you can't see them from inside. And also, by looking around the house, you get a sense about where is the best place for the detector. Now, you're obviously going to have to go in the house and look around the house as well from inside, but an outside perusal is useful to start with. At this point, I want to mention, too, something that was mentioned to me a few years back by a radon tester that I thought was somewhat clever, and that is he would go into the house, and I have what he gave me at that time, and he would meet with the client, and he had the client sign a non-interference agreement. And then he would tell the client, now, here's the charcoal canister I'm going to deploy, and he'd prepare the canister properly. And then he would say, now, and I'm going to deploy it right here, and he would fasten it in some obvious place in the appropriate room. And then he would tell the client, now, I've got to make some notations here, And so he would be left alone, typically for a few minutes. And while he was left alone, he would hide another detector. So we'll call that the hidden detector technique. And it's the hidden detector that he would use to determine the radon concentration in the room. This detector he would simply use over and over and over again from home to home. Now, you can think of some difficulties with that right off the bat. I know you can. Nevertheless, I thought I'd pass that idea on to you. Lock ties we talked about. You may find other uses for lock ties than simply the one use that I mentioned to you, but lock ties are another good idea. Multiple test locations. Here I've notated the hidden detector. You can put radon detectors, of course, you have to put them in the correct prescribed room to begin with, as identified by the protocols, but that's not all. You can do more than that. You can always do more than what the protocols call for. You must simply always do at least what the protocols call for. So if you put a detector in the basement, then maybe you want to put one on the first floor. And then if the concentration on the first floor is significantly less than the concentration in the basement, that's a good indicator that that's probably the way it ought to be. If the radon concentration on the first floor comes out to be higher than what's in the basement, gee, you'd want to think about that. That could be suspect. It could be. You'd have to know something about the heating system in the house and potentially some other details. But that would be an indicator, too. We also mentioned the heat dot for charcoal canisters. I think that's a terrific idea. That, too, would be very cheap and very easy. Educate the client. I think that's extremely important. Again, it is obviously better to deter tampering than to try to detect tampering. A non-interference agreement, I think, is a wonderful idea. As a tester, you don't have any control over what goes on in the house when you're not there. You deploy your detector, you come back a few days later, and you pick it up. During that interim period, during the deployment period, you don't have any control over what went on in that house. And a non-interference agreement will help maintain some sense of control. A house inspection, I think it's a necessity. Excuse me, you've got to look around the house, see where the vents are, what kind of heating system it has. You might want to look, for example, if it has a forced hot air system. Is the fan, is the control for the fan set to automatic? Now, if it's set to automatic, then the fan will go on when the house needs heat. But there's another position for the fan, which is on, typically, and that would leave the fan on all the time. And if it's set to on, then that is not typically the way the houses are run. And so if a client should turn it to on, what that client will do is take some of the air from the basement and move it to the other floors. Potentially, that could be a consideration as to whether or not it was an attempt at tampering. How could you deal with that? Ask the client what position he wants to leave it on, and if it's in the automatic position, then put a tape seal on the switch. You can put a tape seal on anything that you think might be tampered with. We've also discussed the business of detector placement. That is, where should the detector be placed? If you're going into a home, sometimes you'll be going into vacant homes. Or you'll be going into homes that are furnished, too, of course. But there's no guarantee that the furniture will be exactly where you'd like it to be. And so a small test stand is appropriate, especially if you're using something like a charcoal canister or a small passive monitor. Because where are you going to put it? You walk into the room, you look around. Gee, well, I don't know. I'd like to put it here, but there's nothing here, so I think so I'll put it over there on top of the file cabinet. And you put it over there. Well, that may not be the ideal place. If you have a little test stand, you walk in the room, boom, this is where I want it, and the detector goes on it. And I have this other comment over the edge, because I didn't want to forget this one. And that is, if you put your monitor here in the middle of the table, let's say, it's not too hard to cover that. And you know, how are you going to detect the covering of the monitor? Well, as you'll see very shortly, that there is a method to tell whether or not a detector has been covered. But suppose instead I place the detector slightly over the edge of the table, and I put a tape seal on the side of it, a whole tape seal, whoopee, an entire tape seal, like this. Now it's a lot more difficult to cover with a bucket or a pail or even a bag. It's just a lot harder to do. So place it over the edge. Now, what we've discussed are some of the more salient points of the article. We haven't discussed every single detail of the article, of course. It's a fairly lengthy thing. It was a very large undertaking. But I think you'll have some ideas as to what kinds of things you can do to reduce or deter the potential for tampering. Now, it's my pleasure to have invited Bob Lewis from the Pennsylvania DER and several other people to discuss this article. One of the authors of the article is here with us, and they're in the next studio over. So what I'd like to do now is go over to the next studio and meet with them and hear what they have to say about how they performed this particular experiment. So let's go over to the next studio.